Okay, for this problem we're given some of the zeros of the function and we need to generate the function itself. And so the function is going to end up being a third degree, so it's going to have 3 zeros. It tells us that -3 is a 0 and I is a 0, so it gives us 2 of the zeros. And in fact, we have a theorem that says that complex zeros always occur in conjugate pairs. So when they tell us that I is a 0, that automatically implies that -I is also a 0. -I would be the conjugate of I. If we want to think of I as 0 plus I, then its conjugate is 0 minus I, or just -I. So what does it mean for -3 to be a 0? If I kind of work a little bit backwards, if I had my function factored, in order to get a solution that was x equals -3, I would have to have a factor of x plus 3. Because if I set x plus 3 equal to 0, I would subtract 3 from both sides and get x equals -3. So a general way to say this is if we're given that the number c is a 0, then x minus c is a factor. So here we have x minus -3, or x plus 3. So likewise with the i's, we're going to have x minus I as a factor, and then also x minus -I, or x plus I. Now I left some space here in the front because I could throw any other number, any multiple out in front there, and that won't affect the zeros. That would not affect setting this equal to 0 and solving it and getting those same solutions. But the reason I might need that out there is because of this last condition. It says that when I plug a 1 in for x, I'm supposed to get an 8. And so I may or may not get that without a multiple there. And so that's just there to make any adjustments that I might need to satisfy that last condition. So from here we just need to go ahead and multiply out this expression. So I'm going to leave the x plus 3 and multiply the x minus I times x plus I together first. So when we FOIL that, we get x squared plus ix minus ix. So those terms cancel, and then we have minus I squared. Now if you recall, I squared equals -1. So these terms cancel out. That's minus -1, or plus 1. And now we can go ahead and FOIL those last two, so we get x to the third. So we see that it is a third degree polynomial like it's supposed to be, plus x plus 3x squared plus 3. So let me just go ahead and rearrange those terms in order of decreasing powers. So far we've generated a polynomial that meets most of those conditions. It's a third degree polynomial. It has -3, I, and -I as zeros. So the last thing is to make sure that f of 1 equals 8. And so let's go ahead and replace x with 1, and when we do that we know that we're supposed to get an 8 here where the f of x is. Now if I replace x with 1, 1 cubed is 1, 1 squared is 1, times 3 would be 3. And so that all adds up to 8 in there, and so it does turn out that in fact a equals 1. And so our function, then we want to go back to basically this step right here and just replace the a with a 1, which would not be necessary to have outside there. So I just have 1 times that expression in the parentheses, so I can just go ahead and write out that function. So there's our function that satisfies all of those conditions.